This video is actually very important in the sense that you need to take the time to do the actual design work of each of your functions. You can just go ahead and try to hack them together with code if you've got a lot of spare time, both to do the coding and to do the debugging. You're a lot smarter to go ahead and design it out, work out the bugs and the kinks in English before you try to go to the code. And by the way, when you get to the code, all you do is fill in blanks. I want to take a quick step over here into this function right here. This is our main function, and we did this in step 4. And I repeat myself in the sense that this just does not have to be looked at again. This does everything we want it to do. It compiles, and the compiling is important. Once we know it compiles, we don't have to look back to this one ever again. We can just assume it's going to work when we get the utilities completed. So we'll go ahead and step away from that one, and we'll come back here to our string.utils.c file, and we'll get started with step 5. Now, step 5 really is simply writing out the program in English, just as you're doing steps 1, 2, and 3 in the main program. Let's go ahead and take a look at compare string. For our step 1 and mostly step 2, we'll go ahead and just write in what happens. Again, as we've mentioned, you almost always have an initialized function and variables. In this particular case, you're going to have a loop. We'll put in the end loop right there to the end of the shortest string, but we're also going to put overrun protection in all of these functions. And then the only thing to do while we're looking to the end of that shortest string is we need to get the difference in character. We're going to take one character, the left one minus the right one, and get a difference, a numerical difference. If we find that there is a difference, in other words, it's not 0, then we will go ahead and return that difference. We have found a difference, and we found a measurable one that will give us a positive or negative result. And then if we don't find the difference, then we need to go ahead and increment the index and come back looking for the shortest string again, and then end loop. And it's very handy to put this end loop comment in there just to know that you're inside the box here, inside the code block. If you have not found it at the end of the shortest string, and you will want to find the difference in lengths, and that's our step 1 and mostly step 2 because there's not much in there. Our step 3 would then to be note here that the get string length here is going to be a factor for purposes of doing this. And having done that, we still have our return 0. We want to keep this thing still compiling, and I'll show you about something about that in just a moment. Well, this is it. We've got our steps 1, 2, and 3 here, which comprise step 5 inside a function. And so I want to show you something now. We'll just do this once, but I want to show you how to compile just this file. We don't have to compile the whole program. Now, the thing we can do, and clearly in step 5, we're really just not going to change much in the way of code. Nevertheless, I'm going to check this at least one time to make sure it works. I'm going to go at GCC. I always do the dash wall. Then I'm going to do a -C to tell it just to compile it. Don't create a program. And then I just give it one file. Okay, with concatenate string, we'll get started here. There's an issue here we're going to have to deal with related to aliasing, and I'll talk about that in a moment here. We'll almost always start with an initialized function. We're going to copy the source string in case of aliasing. Let's stop and think about this right now. What if somebody wanted to repeat, say, help me Rhonda multiple times? They'd say, help me Rhonda, then concatenate help me Rhonda to help me Rhonda, and they'd keep concatenating it from some string to the same string. Well, what's going to happen is if we overwrite this one, we change this one along the way, as we copy that, we're going to change this string. This is called aliasing. It's very, very insidious, very difficult to follow and find. If the user uses the same source and the same destination, then you're going to do some damage when you try to copy into the destination because you're going to start copying into source. So that's going to be a problem. So we're going to copy that in there. We're going to loop to the end of the source string. This is really pretty straightforward. We're going to assign the characters to the end of the destination string, increment that index, 2 indices actually, and then we'll set the temporary end of the destination string. And once we're done with that, we'll release the memory because we're going to use dynamic memory for this temporary string. We've got some step 2 operations here. We're going to set the destination index specifically. We're going to get the source string length here specifically to be able to do some things here. We're going to create a temporary string pointer and then create the other variables, which I think is just one or two of the indices. So last but not least, for our step 3, we'll go ahead and put in the get string length for this one, get string length for this one. When we create our source string here, we're going to need to create some memory using malloc and then copy the string. And then when we release the memory here, we're going to use the function called free. So that will take care of our concatenate string. And it might make a little more sense when we do get to step 6 on this, but aliasing is a very insidious problem and we have to deal with it. Now our copy string also has the potential for aliasing, so we need to discuss that. Let's go ahead and get started. We're going to put in the initialization of the function. What we're going to do is we're going to check for the source and destination not the same. Meaning, now I'm not asking about data, I'm asking about pointers. Does destr equal sourcedir is what I'm going to be asking. If it does, it means that it's the same pointer. It means the user said my string here and my string here, and they're exactly the same, which means there is no need to copy them. So we simply won't do that. So we're going to checking for not the same, and if they're not the same, we can go ahead and get started with our loop to end of the source string, and this is very straightforward. We'll assign the characters to the end of the destination from source to destination. We'll update the index, and we'll set the temporary end of the destination string. Again, so we can protect that, the destination string will always be a complete C-style string with a null at the end. So we'll handle that. So that right there takes care of that. We simply don't do anything if the source and destination are the same. And that's how we're going to handle aliasing there. So we can continue on now to find substring. Okay, the substring, as mentioned, is going to be a little more complicated. We'll always start, or almost always at least, with initializing the function variables. Inside that, we're going to loop across the test string here and basically just look at that. Hey, this starts with maybe a C. Is there a C here? And if we can find that C, then we're going to start another loop, which I'll show in a second. Start another loop to see if we can identify, we can line up the test string with the search string. Inside that, we'll set the internal loop index to the current test string index, and that's just so we can hang on to the test string index and not modify it. We'll set the internal search index, so that's the one that's going to cross here from 0 to 0. And then we're going to loop to the end of the test string. We're going to keep on going to see if we can find our way to the end of this guy. If we find our way to the end of it before the end of this, we'll return and get out of there, as we'll see here in a second. Here's our loop end here so that we can identify the loop block. This is really going to be important to keep track of that. So I'm going to increment the test string. Hey, are we the same thing here? Because that test will be happening in the loop. I'm going to check for the end of the substring here, which could happen at the end of the substring or at the end of the test string. But we're not going to return that we completed it if we don't count out every single character here. When we do for that, we will return the beginning location of that substring. That's the number that we kept back up here. And then from there, outside of this loop right here, we have to keep on searching till we find a first character to get us started again. So we will increment that current beginning location index. If we've come through the entire loop and we never found our way out of the substring loop, then we're going to have to assume we failed and we'll return that substring not found. Now there are some step 2 components to this one because the initialization takes a little bit more complication here. So what we'll do is we'll initialize as test string length, which requires using get string length. From there, we will initialize a master index. That's the one that's going to be looking through the test stir here and at location of the substring start point. So that's actually here. This will always be 0 at its start point. This is going to keep going upward. And then initialize the other variables here. So now we have this whole process put together here, and we can see that we're going to be ready to do this. So this is probably the most complicated one in the whole set of functions here, and it's really not that complicated. It just does have 2 nested loops here, and so we'll continue from that. So let's take a look at getStringConstrained. Now this is an engine. This is a function that you probably won't use itself, but we're going to write a couple of other functions that actually use it, and use the parameters as needed. However, having this engine function here means that you can create your own other functions or simply use this one as needed when you have special case situations. So here is the getString constrained process here. I may have misspoken a little while ago for the previous one. This one's kind of complicated too, but it's really just to get the job done here. We'll go ahead and initialize the variables here. We will initialize the output string. We'll capture that first value. This is going to prime the loop by just getting the first character here. We'll start the loop to clear the non-printable. This is the leading spaces or non-printables as needed. That's specified up here in the parameters. We'll end that loop so we know what we're working in here. Inside that, we'll get the next character because this loop is really just dumping characters. I checked it. It got me into this loop, and then I'm just going to keep looping here until I get to a place where it is not a non-printable or space, depending on the Booleans there. All right, so when we get through that loop right there, we'll come down and we just first thing to do is make sure that if the end file is found, then we can't go any farther and we can't go get the real data that we wanted. So we'll return failed at that point. Okay, now we're going to loop to capture the real input that we want, and that loop to identify the block. We're going to continue. Now, what I did here is I broke out what this loop looks like so I could really be clear on what the logic was. So I broke this into a couple of different parts here. So this is going to continue if not at the end of the file, and we haven't run past that max string length. And it's going to continue if the non-printable flag is set and characters are printable, or if the non-printable flag is not set. So those are the circumstances for that. Finally, it's going to continue if a specified delimiter is not found, and that will be nullified if it's not used in this particular case, but nevertheless, that's one of the possibilities that might stop this loop. Inside the loop, we'll place the character in the array element, increment the array index, and once again, as I mentioned before, we'll set the next element to the null character, the end of the C string there. We'll get that next character to come back here and check through all three of these tests here, three sets of tests. And we get down here and we return a successful operation, and that's all we need for that. So we've got that all set up. Again, this is probably as nearly as complicated as the previous one, but still not that terrible. All right, get string length. You've seen this before, but we'll go ahead and go through it. So for get string length, remember this is one that just counts characters up to the null character. We'll initialize this guy here. We will loop to the end of the string, watching for that null character. Set our looping block here. Inside, we simply increment the index. That's all we have to do because we're just counting characters at this point. And once we've done that and gotten through the loop, then we'll return that index, which will happen to be the length by that point. That's about it for get string length. You've seen it before, you've written it, so no problem on that. Having finished get string length, we'll come down here to get string to delimiter. This is going to be a really easy one because we're going to go back and use that get string constrained function with specified conditions here. So I'm just going to stick that in there, call the engine function, and do that. And the fact of the matter is when we get down to get string to line end, going to do the same thing here. All right, we're going to specify the constraints. Now we have a lot of parameters in the get string constrained, but we'll set those where we need to set them. Now for get substring, once again, we're going to have a little bit of an aliasing issue here. Let's go ahead and jump into this one and see what we can do. Understanding that somebody may say substring, hey, I just want to take my string and change it all to lowercase without making another string. Just take mine. So I would put my string here and my string here. We've talked about this before, and the fact of the matter is we have to be prepared for aliasing. So let's go ahead and start with initializing the function. We're going to check for the indices within the limits. We're just simply not going to do this job if those indices are outside the limits. If they are within the limits, we'll go ahead and create a temporary string for source string so we don't have the aliasing problem. We'll loop across that requested substring, start to end here. And then inside that, we'll do the good old assigning source character to destination, increment both indices, and then set the temporary end of destination string so it's always a legal C string. And then we will go ahead and return the memory to the operating system for the temporary string. Now we've got some subcomponents for this, so some step 2 items. Set the length of the source string, initialize the index to 0, the destination index, so we're going to start there. Source index to the start index from our parameter, and then we'll create that parameter for the temp string. Not going to make it until we get inside the test here, but we're going to create it here. And then from there, what we'll do for getting this source string right here, we'll need a function. This is step 3 to put this in here. Malloc and copy string right there, and then finally freeing the memory that we created when we did that here. So not a really complicated one, but we do have to deal with aliasing, but they're again starting to look a lot alike when you start looking through all these different functions we've been doing. So no real mysteries here, and that will wrap us up for get substring. Now our set str to lowercase is another one where there's a potential for aliasing. Say, for example, a person has a string and they simply want to take that same string and convert it to lowercase. They don't want to put it in another string. Well, then what they'd likely do is put my string right here as a parameter, and then they put my string right here as a parameter, and then as we go across and change destr, we would be changing their original string, and we don't want to do that. So we have to handle aliasing in this particular one as well. We'll start with initialization. We'll copy the source string in case of aliasing. That's how we're going to handle it. We'll loop across the source string there. We'll set the individual character to the lowercase as needed and assign it to the destination string. We'll update the index, and then we'll add that null character in there so that this is always a legitimate C string no matter where this loop might stop. And then we'll go ahead and release the memory we used for the temp string. Now we got some step 2 components here. We would get the source string length. We're going to need that for a couple of reasons, but one of them is for making a new string. We're going to create a temporary string pointer, and that will be what points at the string. And then we're going to create some other variables. Now that is the program there, that's the function, but we also need to put in the functions we're going to need. We're definitely going to need to get the string length of that source string. We're going to use malloc for the dynamic memory and copy string to make that copy. And then because we made that copy and we need to give back the memory here, so we don't have memory leaks, then we will free the memory at this point. So that gets us to set str to lowercase and handles all of the conditions, including the fact that the user might actually put the same name in both parameters, which would be an aliasing problem. Okay, coming on down to 2 lowercase, this is a pretty straightforward one right here. We're just going to take any uppercase letters if and only if they're uppercase letters, and we're going to set them to lowercase. Let's take a look at that. Easy enough to do. We will test for if we are uppercase. If we are, we'll go ahead and conduct the conversion, send back a lowercase letter. If not, then we're going to assume no uppercase letter and return the character unchanged. We'll just return the same character we picked up here. That's it. That's the end of 2 lowercase, and that's the end of our step 5 here. Again, I repeat myself, your process of doing this won't go as fast as mine. I try to keep these videos as short as I can, but the fact of the matter is you're going to stumble a little bit. Here is the place to stumble. You can stumble while you're writing it in English, or you can stumble it when you write it in code, which multiplies your efforts by at least a factor of 2 and probably quite a bit more. So what you want to do is work your way through this, prove that it works in English, get it done, and then you can go on to step 6, which will be really, really easy after that. So having completed the step 5 here with all of our string utils functions, I showed you compiling the file as its own file to an object file just to prove everything was okay, but we really didn't have to do it that much while we were writing English here. But other than that, we're ready to move on to step 6, which gets really easy when you just have to fill in blanks of do what you told yourself to do. So that will end this video.